Hello, and welcome to this week's episode of the I Am Not Worthless podcast. We are on episode 15, and today I want to talk about math magic and supposed mind reading. We've all seen on TV, at fairs, at amusement parks, somebody who comes up to you and says, "Pick a card." Or I can guess your age. In reality, the truth is this: the universe obeys rules. Tricks, a lot of the times for mind reading, come down to math wearing a cape. Today I'm going to show you and discuss with you how math can explain things like the 21 card trick or the Mobius strip being cut. So first we're going to start with the 21 card trick. Basically, you take 21 cards, you put them in 3 columns of 7. You ask someone to come pick a card, and they will point to which column has that card. You take the piles, you reshuffle, redeal, and do the exact same thing. Ask them to pick the card, pick the card, pick the column, pick the column, pick the column. And then, after you do it 3 times, you will pull the 11th card out of the deck. And it will always be their card. Always. Now, the breakdown is this. When you do it the first deal, you know the selection is somewhere in one of those 7 card piles. So, by placement of that column that person chooses. So when they point to a column, let's say they point to column 2. Well, you basically mix column 1 and column 3 over column 2, and that card will then guaranteed be cards 8 through 14, because that's where you put that column. What if they pick 3? Column 3, same thing. Those cards switch from being cards 15 to 21 and go to 8 to 14. So when you do the deal again, which, by the way, remember, these cards are face up. They're not face down. They're face up. So when you deal it again, those 7 cards from that 8 to 14 are split up into the other 2 columns. When they point to the column again, you're now basically saying, okay, it's now cards 10 through 12. And when you deal it again, the card becomes forced into position 4 of that column, the exact middle of those 7 cards. And so it gets put in the exact center of 21, which is 11. So it's not luck that the person in this situation guesses your card. It's more that the system of how you did it forcing the convergence. Basically, you're running an algorithm. You're basically running a mathematical equation enough times to get the result you want without any chance that it's something else. Variance basically being 0. Even just thinking about it myself, it's amazingly wonderful how you can basically take something and just blow minds. The next mathematical magic trick that I want to discuss is the think of a number. Basically, you ask your participant to think of a number between 1 and 100. Then we say we'll double it, add 10, divide by 2, subtract the original number, and we'll say the answer is 5. So, to break it down, let's say that you chose W. That's your number, W. Doesn't matter what number it is. So you double it, so you now have 2W. If you add 10, it's 2W plus 10. Okay, well, divide by 2. Well, then it's W plus 5. Now you want to, then when I say subtract your original number, that's how you get to 5. Because if you're subtracting the original number from the equation, you're always left with 5. Now, so whatever you add to the equation, and then whatever you divide by, because obviously you don't want to pick add 11, but you want to pick something that's divisible by 2 or divisible by 3, so on and so forth. So you pick numbers in those two spots that match, and that's how you always get that answer being consistent no matter what they pick. The participant thinks they have the power because they chose a number. You would have never guessed what number they would have picked originally. But in reality, like I said, W, the number you chose, doesn't matter. It could have been 1, 5, 20, 30, 99. It would have always come out as 5. And like I said, you could change the 10 and the 2 to be any set of numbers that are divisible into a whole number, and that number will always be what you get. And so, again, you're basically taking numbers and manipulating them to get something that you want, that you always get. The next is called the age guessing. It's age guessing cards. You basically show a participant 5 index cards, each filled with grid numbers. You ask them, is your age on these cards? They point out yes on cards 1, 3, and 4. And without even blinking, you go, you're 13. Here's how it works. Here's why you get the correct answer. Each card is a position in binary. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to 4 is 16. The top left number on each card is its place value. So you have card 1 starting with 1, card 2 starts with 2, 3 with 4, 4 with 8, and 5 with 16. Each integer collection will add up to 30. Each integer adds up to 31. Every integer up to 31 So every number from 1 to 31 has a unique representation in binary. So if one of those cards, one of those 5 cards, has that person's number on it, well, that means that it has a 1 in the binary code. So 13, in our case, in our example, would be represented in binary 1101. Because it will only appear on the 1 card, 4 card, and the 8 card. Basically, all you're doing is reading the top corner number. The other numbers don't mean anything. They could be any. I could put any number I want on there. It could be whatever number I want. And so the audience thinks that you're basically scanning 5 cards, a ton of numbers on them, and pulling it out of your hat, as it were. When in reality, you're just reading one set of numbers. Which card did they say the number was on? Well, then those cards add up to their number. So it looks like telepathy. It looks like you're reading minds. When in reality, you're just doing a simple calculation involving numbers 1, 2, 4, 8, and 16. So if they were 16, they would only have told you card 5. The last bit of magic that I want to talk about is the Mobius strip. So we take a piece of paper, give it a half twist, and tape the ends together. You will get a Mobius strip that looks like an infinity symbol, as it were. We can show you that it has only one edge and one side by drawing a line continuously around it without lifting the marker. Now we're going to take a pair of scissors and we're going to cut it down the middle. You would think you're going to get 2 separate rings, when in reality you end up with 4 half twists, 1 long loop with 4 half twists. Now if you were to cut it at the 1/3 mark, 1/3 of the way from the edge, set it on the middle, you would end up with 2 linked loops, an original Mobius strip, small, and a larger loop. Topology is what we're working with here, and it's the study of geometric properties that remain invariant, unchanged, under constant deformation or change. So when you cut a non-orientable surface like a Mobius strip, you're not going to destroy its topological structure. You're showing how space folds, and it's not always in Euclidean or mathematical ways. Magic with numbers and mind reading relies on the audience assuming randomness. Math magic relies on the performer, the magician, enacting strict boundaries. So once you understand how that mathematics works, whether it's algebra, binary code, topology, you find out that in reality, the real mystery in magic is how you could predict things in the universe much more easily than you thought was possible. So I'm going to say to you, try one of these tricks. Try the think of a number trick, try the 21 card trick on someone, and see if you can get the right answer, and see if they could see that you got the right answer. Thank you so much for listening to this week's episode of the I Am Not Worthless podcast. I will see y'all next week. Be safe, stay cool, stay hydrated. Peace out.